Good morning. Today for this lesson, we are going to learn about MAD or mean absolute deviation. This skill is a bit challenging at first, but if you know how to calculate mean, it's going to be easy. We're not going to go through the Eureka lesson today. What I'm actually going to use is the exit ticket. The first thing I'm going to talk about is what is the MAD? What is mean absolute deviation? Mean absolute deviation is used to determine variability. Now, yesterday we talked about what does data look like. Is it spread out? Is it clustered? The more clustered the data, the lower the variability, which means the mean is a greater indicator for that center of data. So you want your data to have low variability. When it's high variability, the data is spread out, and the mean isn't really an accurate indicator of that center of data. So I'm going to switch over to the exit ticket. And the first thing that it talks about is the mean absolute deviation is a measure of variability for a data set, like I just said. And what does a data distribution look like if its MAD equals 0? I'm going to show you what that data set looks like, and then I want you to kind of think about what that means. So the data set that we're actually going to be looking at is City A. City A has an MAD of 0. What do you notice? Well, for that, all of the data points are on the same spot. Now, what does that mean in terms of variability if it has 0? Well, the lower the MAD, the lower the variability. So 0 is as low as it can go, It has low variability. It's the lowest that you can go for 0 for City A. And you'll see that there's a bunch of other cities in your lesson. But City A has an MAD of 0. And if you were to calculate that out, you would be able to prove that that has an MAD of 0. So when an MAD has an MAD of 0, all the data spots are all the data points are in the same spot. Is it possible to have a negative MAD? It's not. Or I'm sorry, it is. Or is it possible? It's impossible. It's impossible. The reason being is because the MAD use absolute value. And remember, absolute value when it's a number inside of the absolute value sign, that's always going to equal a positive. So it's impossible. It will either be 0 or a positive number. It is impossible. So now here you have a data set, and I'm going to walk you through the steps on how to find MAD. You are going to want to use these steps every single time. All right? My steps are right here. So the first thing that you're going to need to do is calculate the mean of your data set. The second thing you're going to do is determine the distance from the mean for each data point. Then you're going to add those numbers up, and then you're going to divide by the number of data points. The lower the MAD, the lower the variability. The higher the MAD, the higher the variability. So I'm going to walk through what does this mean in terms of actual practice. So they have your data set right here, and Eureka was really nice. They told you what the mean is right here. So calculate the mean, number 1, already done for you. They tell you that the mean is 3 for this data set right here. Now we have a chart. It has all of the students 1 through 7 since there's 7 of them, and then it has the data from least to greatest. Now what we need to do is we need to calculate the deviation from the mean, the distance from the mean. Distance from the mean, okay? So what that means is I am going to use absolute value. So I'm going to take the mean and I'm going to subtract that from whatever this number is. So I'm going to actually do that over here, 3 minus 1. It really is that simple. And that equals 2. So I put a 2 there. Okay, whatever that is. And I can actually fill that in 2 more times because same data points. Now I'm going to use this number. 3 minus 2 equals 1. 1. Now I know that this number is greater. So whatever number is greater, I'm going to subtract that one. So 4 minus 3. It doesn't matter what order it is, as long as you're taking one of those numbers has to be that mean that was calculated from that data set. So 4 minus 3 is 1. 1. 1. 8 minus 3 equals 5. Okay, direction from, or distance from the mean. Now it does say direction, but right now I am not going to have you focus on direction. I really want you to focus on what is the distance from the mean. So if my center of data is 3, how far away are all of these data points from that? Well, it's 2 points away from it, 2 spots away from it, 2 spots, 1 spot, 1 spot, 1 spot, 5 spots. Okay? Now it says absolute deviation from the mean. It's the exact same column. Okay? It's the exact same column. So it's 2 from, 1, 1, 1, and 5. Now it's asking you to add these up. The only column that I want you to add up is this last column, because in your third step is you're going to add those new numbers up. So whatever you got from that distance of the mean, we need to add these up because now we're going to calculate a new mean. We're calculating the mean of the absolute deviation. So when I add these up, I'm going to get 14. The fourth step in calculating the MAD is to divide those by the number of data points. Well, it's just like the mean, so I have 1, 2, 3, 4, 5, 6, 7. So I'm going to take this sum and I'm going to divide it by 7. So the MAD is 2. Now I'm going to go to my last question. Explain in words what the MAD means for this data set. It's asking you, when it asks you to explain what the MAD means in terms of data set, it's asking you for, does it have high variability? Does it have low variability? The lower the MAD, the lower the variability. The higher the MAD, the higher the variability. Okay? Now, you want to think about how close is this from 0? It's 2 points away from 0, so from what I see, it has low variability. And then you want to compare it to how close is it to the mean. Well, it's pretty close. It's pretty darn close to being close to that mean. So we can say that it has a pretty close center of the spread of data. But I kind of want to prove it a little bit further. What I'm going to do is I'm going to draw a quick dot plot of our data set to kind of look at that spread of data. So give me a second and I'll be right back. So what do we think? Here's my balancing point. That is my mean. And right now my MAD is 2. What do you think? Is it pretty accurate? Is it pretty clustered? Now, I would say that most of it's pretty clustered around here with one outlier. So when I'm asking for it to explain what does the MAD mean, I would say that it means that it has lower variability, not super low, but it has lower variability with really one outlier. I would say that this data is pretty clustered, even though that it's not directly over the mean, it's clustered around here. So it has lower variability or clustered data with one outlier. Outlier, again, means that it doesn't really fit in this data point. It's very skewed. It brings it over because this would be a skewed right graph. It would not be symmetrical if you can see that. It's got this empty data over here on the right. So that is calculating MAD. Again, here are the steps that you can use to have up when you are working through your homework. The homework that I want you to complete today is I want you to complete, let's see, I want you to complete number 2 and number 3. So use these steps to complete number 2 and number 3. Staple your exit ticket to your homework following that.